Chapter 4. A Consumer Curiosity? By 1947, Land had moved into his own laboratory and office, separate from the rest of Polaroid's operations, and located in a building just across the street from Polaroid's facility at 730 Main Street in Cambridge. It was an old brick two-story factory building at 2 Osborne Street, sandwiched between Harvard and MIT, and had an important place in the history of technology. There, Thomas Watson had received the very first two-way long-distance telephone call from Alexander Graham Bell in 1876. In the wake of the publicity generated by the New York City demonstration, anticipation for the public release of Polaroid's one-step system was high. Unfortunately, Land and his colleagues were not even close to being ready. The technology was close, but not the final designs of a mass-producible version of the camera or the film. Getting there would take almost 2 years. During this period, business for Polaroid continued to decline. The profitable military sales from the war years had dried up as expected. Fortunately, a special tax provision provided the company with funds sufficient to carry on. During the war, the government had instituted an emergency tax on what were characterized as excess profits made during the war. Congress had first passed this kind of provision in March 1917 to limit excess profits made in World War I, as well as to raise revenue to fight the war. President Franklin Roosevelt brought it back in 1942 for World War II. However, once the war was over, in order to support the transition to normal economic activity, the tax code was amended and the taxes paid rebated to companies like Polaroid. Land's plan for his commercial one-step product was to secure supplies of the negative component from an outside source. His company would then manufacture the positive, or image-receiving sheet, and assemble it with the negative into the composite film for sale to the public. The positive was really the unique structure in the process, and that is where all of Polaroid's research efforts had been directed. All of the imaging experiments done by Muller, Land, and others had used a standard Kodak black-and-white photographic silver halide emulsion. So now Polaroid turned to Kodak to provide a negative containing the same standard emulsion for its commercial film, but this time coated on a paper base. Land had anticipated this arrangement when he made his 1946 presentation to Kodak's Kenneth Mies. Sure enough, Kodak agreed to sell negative to Polaroid for a fixed price. In this, Land's second deal with Kodak, the vendor-customer relationship was reversed. Instead of supplying Kodak, Polaroid became Kodak's customer, and by the late 1960s, it ranked as one of Kodak's top 3 corporate accounts, alongside R.J. Reynolds and Philip Morris, cigarette manufacturers, for whom Kodak provided cellulose acetate filter tips. As a result of this new relationship, and to enable it to do the best job, Kodak was interested in learning more about the process that Polaroid was working on. A special arrangement was made, whereby some Kodak scientists, led by Henry Yutzi, would come to Cambridge, so Polaroid could show them what it was doing. In terms of intellectual property, the agreement provided that any inventions made by Kodak in the photographic diffusion transfer field, as a result of the work it was doing for Polaroid, would belong to Polaroid. However, Kodak would have the option of using any of Polaroid's technology in the document copying field. It was the start of a unique, cordial, and cooperative relationship between the companies that would last for more than 2 decades. While Kodak's management had no interest in getting directly into the field of one-step photography that Polaroid was pioneering, they were very supportive, mentoring Land and his colleagues. As development work at Polaroid on the positive part of the film sandwich continued, Polaroid decided that the images in the first consumer version of the film were going to be sepia-toned, as had been the case in all of the early public demonstrations of the process. The sepia color of the image was due to the chemistry of the process. Development produced a brown-silver colloid that diffused to form the image, rather than a pure black compound that could produce a black-and-white image. In the early stages of the research, this chemistry had proven easier to adapt to the diffusion transfer process. Much more additional work would be necessary to modify the imaging chemistry to form the kind of silver compound necessary to achieve black-and-white images and to develop a different kind of positive sheet to receive it. The initial sepia film was marketed as Type 40 Polaroid Land Film. It also soon became apparent that the consumer version of the system was not going to be able to operate like the demonstration models. In those, after the shutter was tripped and the film exposed, the negative and the positive were brought together, and the resultant sandwich was advanced through the rollers and out of the camera to develop in the ambient light. But the paper used to make the commercial version of the film was not opaque enough to prevent unwanted additional light from reaching the photosensitive layer of the film after the film exited the camera, but before processing was completed. The film used in the demonstrations had been made by hand, and thick paper supports were possible. The camera mechanism had also been custom designed to accommodate the thick supports of this demonstration film. But a consumer version would require thinner paper film supports for both mechanical and economic reasons. If the paper material is too thick, it would be too stiff to rotate properly around the rollers, making it difficult to get the proper spread of processing reagent. Also, paper thick enough to be opaque was going to be costly. As a result, the first commercial camera, the Model 95 Polaroid land camera, was designed so that the negative and positive sandwich stayed inside the camera. After a minute, once the processing was done, the camera back would be opened and the print peeled off and lifted out. As it turned out, the kind of idealized camera and film system used in the demonstrations, which allowed for out-of-camera processing of peel-apart film, would not actually become practicable until the 1960s. The design for the Model 95 had interesting features beyond the special components necessary for the one-step process. It was the very first to employ drop-in loading of film in any camera that used roll film. Other cameras of the day require the user to thread the film through one end of the rear part of the camera and onto the take-up spool on the other. The Polaroid film was completely different because it comprised two spools, one carrying the rolled-up negative material and the other carrying the image-receiving sheet material with the pods positioned in between image lengths. A paper leader on the starting end connected these two lengths of positive and negative on their respective spools. To load the Model 95, one opened the back flap and simply dropped the two spools into place on opposite ends of the camera. Then the photographer slipped the leader through the slot to the outside, shut the camera, and then pulled the leader, advancing the film into position for taking the first picture. Another notable attribute of the Model 95 was the weight of the camera, which was the result of pragmatic considerations. At the time, there was a fairly high federal excise tax of approximately 25% charged to purchasers of amateur cameras, amateur being defined as weighing less than 4 pounds. Since it was already apparent to Land and McCune that their camera was going to be relatively heavy anyway, they made sure that the Model 95 weighed more than 4 pounds, so it could avoid the tax. Today, when one lifts one of these original cameras, one is struck by its massive weight as compared with cameras of more recent vintage. It was truly a solid, yet sophisticated piece of equipment. Land's initial philosophy was that Polaroid should manufacture as little as possible on its own. Instead, it would rely on other companies, including one to build cameras to its specifications. Once the design for the Model 95 camera was complete, Polaroid contracted with an outside firm, Samson United of Rochester, New York, to manufacture it. The firm had been recommended to Polaroid by one of its Kodak colleagues. This arrangement proved to be short-lived as Samson United went bankrupt, forcing Polaroid to switch suppliers in 1952 to another company, U.S. Time, later known as Timex of Middlebury, Connecticut. On the film side, Polaroid assembled the final product from negatives sourced from Kodak with other elements, the positive image-receiving sheet, pod, and processing composition that it manufactured itself. Land soon learned that there were clear disadvantages to having outside companies involved. It made it more challenging for Polaroid to keep quality control to the very high standards Land required and to maintain control over the invaluable intellectual property that would inevitably be generated by the process of adapting Polaroid's products from the laboratory to mass production. Over the years, these issues and others led Polaroid eventually to manufacture most of its own critical components.